In this video I'm going to show you how to bring in a gear from AndyMark and set it up for assembly. I'm here at on AndyMark, part number AM-2565. Come down to Files and Documents, and you notice there's a CAD file here. I'm going to right click on it and save target as, and I'm going to save it in my Fembots 2016 folder. Just leave the name the same. Go ahead and hit save. I'm going to go ahead and go to Inventor, and I'm going to go ahead and open that part. Notice I'm specifying a step file, and it's right here, so I'm going to go ahead and open it. So I'm going to add an axis to the part. Notice that here there's a folder of the axis that I'm going to create actually already exists, but these you really can't you can't turn them on and off. They're there as references, but so I'm going to create a new x-axis that goes through the center of the part, and to do that I'm going to come up here to Axis and create a new axis through intersection of two planes. So now it's asking me to select the planes, and I'm going to select this XZ plane and the XY plane. And now if you notice, there's my axis, and it's down here, work axis 1. And I'm going to call this, I'm going to rename it, call it axis rotation. I'm going to create a new plane for alignment. When I align this to a hex shaft, I'm going to need a work plane to align. So if there's a plane on the hex shaft and a plane on the gear, I could just align those two planes. It makes it a lot easier. So that plane actually already exists, but it's here. It's under the origin, and I want it out here outside of that folder. So I'm going to create a new work plane, offset from plane, and I'm going to you notice that this plane goes through the two vertices of the hex, and so that's exactly how I want to align it, use it as an alignment plane. So I'm going to click on there, and I'm going to have an offset of 0, hit enter, and now here's my new work plane, and I'm going to go ahead and click here just before the name of the plane, just before the W, and that'll let me rename it. I'm going to call it plane hex. I'm going to create two more work planes, one that goes through the center of the tooth and one that goes through the trough. And most likely one of those already exists because when they design it, and it in fact is this one right here, the XY plane goes right through the center of the trough of the key. And so I'm going to duplicate that. So do the same thing, offset from plane, and I'm going to choose the so let me try that again. I'm going to do offset from plane, and I'm going to choose this plane here, the XY plane, and set an offset of 0, and there's my new work plane. And I'm going to call it plane trough. So I'm going to create a new one that goes right through the center of the tooth, and so to do that, I'm going to pull up my calculator. And this has 42 teeth, so I'm going to divide 360 divided by 42. But I'm not going over an entire pitch. I'm not going from here to here. I want to go over a half a pitch, so I'm going to divide this by 2. And that's 4.2857. So I'm going to create a new work plane at an angle around an edge. And that edge I'm going to use is this axis of rotation that I created earlier. So it's asking me for a plane. I'm going to choose this plane, and it's asking me for an edge. I'm going to choose this axis. And now it's asking me for a degree, a measurement in radians. I'm going to type in the degrees. You have to specify degrees, so I'm going to type in 4.2857 and the space DEG for degrees. And you notice there's my new work plane right there. But one thing that it did, so I'm going to rename that. I'm going to call it plane tooth. But one thing that Inventor did is that it buried my other work plane here underneath because it thought I was using it just as a reference. But in fact, I'm going to bring it back up here so that they're both at the root level. So I have my axis of rotation, my hex plane for lining the hex shaft, and my trough goes to the trough, and my plane that goes to my tooth. Now I'm going to create a cylinder for aligning gear to gear. So I'm going to create a new sketch on that face, and I want to grab the center of that gear. I want to make sure I grab the center, and I'm going to go back to Andy Mark, and you notice that under the description it tells you what the pitch diameter is. It's 2.15 inches. So I'm going to create a circle at the origin, making sure that I grab that origin. It's very critical. And 2.15. And there's my circle. I'm going to hit the green check. I'm going to extrude, but I'm not going to extrude a solid into the body. I'm going to reverse the direction, but I want to create a surface feature, not a part. I don't want to superimpose a feature over a part. I'm going to go to this surface here, and there's my cylinder. I'm going to hit OK. And if you notice that it's created my surface feature. It's right here. And I'm going to call it pitch diameter. And so there's my part, my fully documented part. I'm going to go ahead and save it. I'm going to save as, because I want to make sure where I'm saving it. I'm going to go ahead and save as. And you notice what it wants to do. It wants to store it where in the downloads directory. I'm going to go ahead and it wants to store the imported components folder, and I want to store it in Fembots 2016. So I'm going to store it here. I'm going to hit save. I'm going to create a new assembly, and I'm going to place that part. Place the component. This gear. Well, here again it's Fembots 2016. That gear there. I'm going to place it. I'm going to place two of them and hit OK. So I'm going to go back to the first one, and I'm going to ground that part so that it can't move. And now I'm going to add a constraint. I'm going to use a flush constraint, and I'm going to make that surface flush with that. Hit apply. Now I'm going to add another constraint. I'm going to use the tangent constraint this time. And I'm going to align those two features that I created. I'm going to make that tangent to that. Hit apply. And you now notice now that remains, this remains tangent to that. But if you notice, the teeth aren't aligned. So I'm going to go back and I'm going to open up my 2 gears, and I'm going to temporarily create a constraint to align the gears. So I'm going to use an alignment, and I'm going to align the trough plane in one gear to the tooth gear on the other, and hit apply. Now if you notice, the 2 gears are aligned now perfectly, but they can't move because I've fully constrained it. So I created that just as a temporary measure. I'm going to go ahead and suppress that. Okay, and now I'm going to create a new constraint, and that constraint is going to be a motion constraint. And the gears are going to rotate in opposite direction. I'm going to rotate around, and I'm going to specify that face and the other adjoining face, that face there, and hit apply, cancel. And now you notice that when I move a gear, move one of the gears, it rotates around the fixed part, and they're aligned. Of course, if I had this grounded to a shaft, so this is just for simulation. I'm going to show you another way of doing this. This is really just for animation to see if your gears are aligned, but I'm going to show you a different way to doing it using so you could simulate the gears moving. But for right now, this is the first step, just showing that just so you could show that your gears are, in fact, are aligned. And if you had one a shaft, this attached to a shaft, and you rotated the shaft and this rotated, it would turn this. So, but right now, the way I have it situated, they're just going around one another because I don't have the shafts in place or the bearings or the motor. So that's how you simulate the gear motion.